Hello everybody. So today we're going to be talking about ancestors in trees. So there are a lot of algorithms involving trees, and I'm going to be talking about those algorithms in the next few videos. And one of these algorithms is algorithms surrounding ancestors in trees. So algorithms like finding common ancestors, which we'll talk about today, or just finding the nth ancestor for a certain node. So let's get right into it. So first of all, what is an ancestor? So when we talk about ancestors, we mean the node that is directly above a certain node. So in a tree, there should only be one ancestor of a node. There shouldn't be two ancestors ever, or at least in like a tree shaped inside, a tree shaped in like this order, right? Shaped in a tree order. I'm not sure what the correct term is because I forgot, but there should only be like one ancestor for node 7, and that ancestor is 4, and all of these nodes share an ancestor of 1. And so one of these algorithms that involve calculating ancestors is the nth ancestor problem. So the problem is, how would we find, say, the third ancestor or the second ancestor of 8? So here, the second ancestor, by the second ancestor, I mean like the ancestor of the ancestor, so second ancestor. So here, the second ancestor would be 1, 2 would be 4, right? So how would we find this in an algorithm? So the easy answer is just to traverse up the tree until like an n number of times. So if we want to find the nth ancestor, say we want to find the third ancestor, this time we just traverse up the tree. So like 1, 2, 3, third ancestor, 1. So yeah, that could be one way, but that is actually a bad time complexity. So since it's a O(n) time complexity, so we could have like a tree that's just like just one single chain, and then you have to traverse all the way up the chain, right? That's not very efficient at all. So one other algorithm that we could use is we could create a table of sorts. So say we create this table, and then we could have all the nodes here, 4, 5, 6, 7, 8, right? And then the nth ancestor, and here, 1, 2, 3. So what we do is we process each of the nodes in the graph. So what is the first ancestor of node 1? So it is 0. So there is no ancestor, so we do 0. And then the first ancestor of 2, we see that it is 1. And then 3, the ancestor of 3 is 4. And then the ancestor of 4 is 1 again. And then 5 is 1. Then node 6 is node 2. Node 7 ancestor is node 4. And then node 8's ancestor is 7. And then from here, we don't need to traverse the graph anymore. We can just do this automatically. So we can see that, okay, so the second ancestor of node 1 will be 0. And then the second ancestor of node 2 would be 0. And then the second ancestor of node 3. So from here, we can just go through the array and then find the first ancestor of node 4. Since the first ancestor of node 4 would be the second ancestor of node 3, if that makes sense. So it would be 1 right here. And then the second ancestor of node 4 would be the first ancestor of node 1, which is 0. And then the second ancestor of node 5 would be the first ancestor of node 1, which is again 0. And the second ancestor of node 6 would be the first ancestor of node 2, which is 1. And then for 3, it's the first ancestor of 4, which is again 1. And then the first ancestor of 7 would be 4. Here again. And then if we want to do third ancestor, it would just be all zeros except for 8, sorry. Just randomly set a number. Alright, so this is one algorithm where we find the nth ancestor, so we can just create a table just by traversing the first level. And this processing algorithm takes n log n time, since for each node we have to calculate log n values, so n log n, which is better than n. And then another algorithm that involves ancestors would be finding common ancestors. So basically we want to find the first node that is shared between the ancestry of like 2 nodes. So for example, the first common ancestor of node 3 and node 8 would be node 4. But like, how would we find that in an actual algorithm? So we can just use 2 pointers. So we've used pointers in the last video, I think, or in a previous video. So we can just start with a pointer in node 3 and then one in node 8. So what we do is we move the lower nodes pointer until they're on the same level. So in this case, we just move it up 1 level. So here, and then at this point we will they're on the same level, right? So we just keep moving both of the pointers up until they're at the same node. So in this case, we don't have to. We can just move 1 level onto node 4, and then we have found the common ancestor. And say if the pointer was pointing at node 6, we can also keep moving the 2 pointers up simultaneously, and then we end up arriving at node 1. So yeah, this is one algorithm to find the common ancestor of 2 nodes. Hope you learned something new today. Bye-bye.